There has been a lot of updates in the Google I/O last week, but one particular update was amazing about integrating NVIDIA's GPU cuDF inside pandas inside in Google Colab. So they had released this GPU in March, but now in the Google AIO they mentioned that now they have integrated NVIDIA GPU CUD4 into your Google Colab, and all of us here can start using this feature this by just installing a package, and the setup is just 5 to 10 minutes. You can do that setup and you can see the difference that is going on. So I will quickly show you a quick demo of this application that is there. So if you are seeing this particular update, what it is actually doing, it is increasing the way you're talking with pandas. What is panda? It is a package where we talk analyze data and derive value out of the data sets, and the data sets can be huge. They can be millions of rows, and pandas, using pandas are a little bit slow. There was a new package called Polaris which was faster, but now you can use the same panda, your same code that you are using before CUDF, rapid CUDF. Now you can just do that quicker and faster, and we will show you the use case. And this has been in the launch, this particular in the IO 24 event. Laurence Moroney, the head of AI Advocacy, announced this particular thing, and this tool is going to be used by a lot of developers, and this is a very great initiative. And you don't need to do any changes in your pandas code. You just need to install the wrappers that are there for rapid CUDF and start working with it. So now I will just quickly show you the notebook here. This is the notebook. This link will also be shared on it will be shared on the video as well, so you can have a look at this video. And coming to this, if you can see what is actually happening, this is giving you a detail. You need to first install the setup. You need to get the NVIDIA SMI, and once you run this particular code, I will start running it in front of you, and this is really helpful in lot of data manipulation that we do it in Panda. So once we run this particular code, and I'm running it live in front of you so you can have a look. This is these are the NVIDIA SMI. It is using Tesla T4 processors, and all the details about this is given. Then we import CUDF, which is this should work without any error. And now what the data that we are using here is parking data set for violations in the fiscal year 2022. This is from Open Data of New York. We are downloading a copy of this data set from an S3 bucket hosted by NVIDIA to provide faster download speed. We will start the download from this data. So you need to first do this wget and get the whole data that is there, this open data from the New York parking violations, and we are going to, it will just take a couple of seconds. Right now we are using pandas, and so it will see the time as well. So now we all know, whoever are been following our channel and our community for a long time, we have done a lot of session on pandas, and this is a normal, you can say, if we are reading the file, we are reading this file of violations, and we want mainly 5 columns, that is the registration state, violation description, vehicle body type, issue date, and summon number. So this is what we are able to process from the panda library that is there. And this is the data set that we get, very simple data set. They are giving us the different violation description, violation type, and the data, and this is real open data that is available, and it is masked for removing the personal identity information that is there. Now we will start asking specific questions about which parking violation is the most commonly committed from the various state. So if you can see, now we are going to see what is the most commonly committed. So now we want to see from the description type. From the description we want to see which is the most common type, and from various US states. So which is the, when we run this code, Let me just let me get the info of this data just to show all of you how much is this data set, how big is this data set, just to do an info. This data set, if you can see, is 58.88, 1.133. So it is 1.5 million rows of data. It is more than 600 MB of data. It's a big data. And then what we are doing is we are for every state, at every state level, we are seeing which is the most common parking violations. So if you can see, we are grouping by state. So we are getting grouping by state, and then we are counting the number of value counts of the registration state and the violation description. So in state AB, in state 99, with their missing value, this is the violation. Photo school speed violation 3668. So this is the whole data that we are getting of all the different rows and all the different states and what are the top violations. So this is happening. Let me run this code and you will see how much time will this code take in pandas. So this is it coming up. This is the next code that is for the vehicle body type that are frequently involved in. So SBUN is the most, and the different things that are there. So these are basic panda codes. I don't want to go in details, but the whole purpose of this video is to show how fast the panda is working. So this is across the day you're getting this information, and now we will time everything. So we will time all the code that we are going to use in panda. First is reading the file. So it is taking some time, if you can see, and every question that we are trying to do, so it is taking us 8.567 seconds total time to run this the first code that is there. So now this is the first part when we want to get the registration state and the violation. So this one is there. Now we are going to time the next one. So you can see this one is, we are timing the count of the vehicle. So 944, this was a little bit faster. And the last one, the weekday question, which weekday is running, this is also grouping by a lot of things, and it took 4.3 seconds. So the first one took 8.56 seconds, almost 9 seconds, and the last one took 4 seconds. Now what we are going to do is we are going to restart the kernel, and we are going to use the cuDF panda. So we have restarted it. Now we are loading. Okay, let us run this again. Let us restart. It is okay. Your system automatically restarting. Okay, now this is restarted. Now we'll start running this. Now we are just loading just one code. Load external cuDF.pandas. That's it, nothing else. Already our packages are there, everything is there. Now we are going to run this particular, we are timing this. So the first code that took loading the data and running the code, it took us almost 8.56 seconds, and this is 974 milliseconds. So you can see the light difference that is there. So this is approximately more than 20 times faster. Similarly, for this question, this will, if you see, it is running 31 milliseconds compared to 944 milliseconds that happened on the normal pandas. So this is the speed at what it is running. Now we have the last one, which took around 4 seconds regarding the weekdays at which the issues are happening. 307. So this is almost 100 times faster that it has ran. So understanding the performance, so this is very good. Now just to understand the a little bit performance of how these things are working behind the scenes, we will just look into provides profiling utilities to help better understand the performance. With these tools you can identify which part of your code ran on the GPU and which ran on the CPU. So just let us see, this is the length of the data. Just want to see how they are splitting it and looking into this particular scenario. So these are the behind the scenes how the things are working. And but the whole thing is for you to get an understanding that Panda cuDF is very fast. So you can see the details that is giving the data frames. It took this much seconds, concatenation took this much seconds. So you can analyze this, you can play around with this, and then you can decide how to make your code better. But the whole purpose of this quick video was to show how Panda cuDF is making your code faster. So suppose now you're using Google Colab and you are working with more than 10 million or one of data set, or even 1 million or plus more data set that is there. You can use this package with just 2-3 lines of code. You can just import the library, run one line of code and try to execute, and you get faster outputs that is there. So the code and everything will be shared. Thank you for watching this video and see you in the next.